For this next problem from chapter 4, it's going to be similar to the previous problem where we have a known set of roots and we have to try to find the polynomial using factorization theorem. That is, given the building blocks, how do we build a polynomial? So we know from the graph that this is -1, 1, and 2. And those are all roots. So f of -1 is 0, f of 1 is 0, and f of 2 is 0. And again, it's stated in the problem, and it's pretty obvious from the graph, that the y-intercept, f of 0, is equal to -2. Now, we can put this all together in factorization theorem and say that f of x is equal to a times x minus -1, so x plus 1 raised to some power, times x minus 1 raised to some power, times x minus 2 raised to some power. Now, if all of those powers were 1, this would be a cubic, which it's clearly not. So what we're dealing with here is roots of multiplicity. That is, these roots are repeated, some of them not. And the way that you can figure out which ones are repeated and how often is by looking at the behavior of the root where it crosses the x-axis. So let's start out with the x equals 1 corresponding to this factor. It goes straight through, doesn't hesitate, just goes right through it. So we're inclined to think that the exponent there should be 1. There's no repeated root necessary. At x equals 2, corresponding to this factor, notice how it tries to go down through the x-axis, but it also has this urge to go upwards. The result is this tangent that's almost parabolic in nature. And that means that we've got a second power on x minus 2. Here, it wants to go through the x-axis, then it kind of wants to go up and then back down. It's having trouble making up its mind. That's because it has a multiplicity 3. It goes through just like a cubic would. So add all these together and you'll get an x to the 6th, which makes sense given the situation. So now what we have to do is find a. So we plug in f of 0. F of 0 is going to give us a times 1 to the 3rd times -1 to the 1st times -2 squared. All of this together is going to give us a total of -4a, because the -2 becomes positive, negative, positive. And we know that this equals -2. So divide by -4, a equals 1/2, and our polynomial f of x is finished with a 1/2 x plus 1 to the 3rd times x minus 1 to the 1st times x minus 2 squared. And that is the polynomial that is depicted.